Today we are in Sweden, in Stockholm, Prologis warehouse facility, where we are doing a full-scale test in cooperation with Prologis and ABT. It is very important for Primx as it will work as means to help us open new European and global markets. It is the right choice for companies that have very high sustainability goals and that demand that concrete floors in their facilities are future ready for automatization.
What was brought up is if we have two leg loads of warehouse racking adjacent to a joint, what would happen? And the idea is that the load will be transferred for almost half of it to the other side through the joint. It's difficult to calculate it, so the only way to really know is to test it. We've seen 50% overload over normal load already and no cracking and no real deformations that you can see of, so it performs even better than I would have expected. We have to really understand things. So slabs on grade are difficult to understand, to how they exactly work. And if we over-engineer, it's safe, and until recent that was enough. Make it safe and everybody's happy. But now we want it to be safe, but we also want it to be durable and sustainable. We don't want to use more material than necessary. And then we really have to get deeper understanding of how such a slab performs. So we can see if we can take off thickness of the slab or take out rebar in order to get to a very low impact with carbon emissions, material use, etc. In construction, we have to understand that we need new technology in order to solve the demands for the future. So it's not possible to use the solutions of the past for the challenges of the future. For example, steel fiber concrete is not normal to use in construction. The low shrinkage technology or chemical post-tensioning is not common to be used in construction. We need to have high functionality. So you need to be able to use it in the best possible way. We need it to be durable. We don't want a lot of maintenance. Basically, we want it to live forever. And the third thing is that we want it to be sustainable. And with the solutions from the past, if we improve one, we most of the time decrease another one. So we have to use new technology to increase all three. So we need to find the technology that increases functionality, increases durability, and reduces the carbon impact or the material use.
In Primx, we are really committed to making the data-driven decisions about how to build the best possible floors. And for that to happen, we have an extensive research program that is partially being conducted in our lab, where we understand what is our material, but also we have a lot of full-scale tests that we are organizing all around the world. And this is one of the series of the tests looking at various different aspects of the floor. This particular test is concentrated on understanding what is the load-bearing capacity of the slab very near the joint for a slab on a grade solution. And what we want to understand and see what exactly is the behavior of the Primx slab when it is loaded fully and loaded exactly near the joint.
So we do this proof loading where we simulate a back-to-back configuration. These basically are the two legs of a storage rack. And we have the service limit state 80 kilonewtons per single leg, so 8 tons. We simulate this with a steel frame, on which we add steel plates to simulate the actual loads. One steel plate equals about 2 tons, so we have in total 17 steel plates to achieve a service limit state loading, and up to 25 steel plates to go beyond the service limit stage and up to ultimate limit state.
The result is that we loaded more than 60 tons on 4 legs and 2 legs very close to a joint, and we saw that the joint holds very well. So we know now that we can load very high close to a joint, and we saw slightly cracking, some minor cracking, very low crack width, 2 cracks circular around the leg load, and that shows us that the structure is very well capable of confining the crack width and also distributing the load over more cracks, which is very helpful because that increases the safety of the slab.
We have exceeded our expectations. Without cracking, we loaded it up to SLS state, up to ULS state, and in the end, at 64 tons and 32 tons in back-to-back case near the joints, we saw first higher line with cracks, so the results are very good.
I would like to emphasize that Primx is truly thankful to Prologis that we can, in fact, execute this full-scale test in one of their facilities and in such a way prove the outstanding load-bearing capacities that Primx concrete flooring provides.